Okay, now come to the today class. So I think we have seen in the previous class just applications of the line integral. So in the previous class, I think in the line integral, in the starting class, we have seen some problems, path problems. The first question is related to the parabola. Second question is related to the, again that is also related to parabola. And third question related to square formed by plus or minus 1 and plus or minus 1, x is equal plus or minus 1 and y is equal plus or minus 1. And the fourth problem channel, fourth problem, no, okay, no, okay, here there is a fourth problem, yes. So this is the fourth problem. So this one, it is the circular path, but these problems are very lengthy. Now the same line integral problems will convert into the double integrals by using the theorem. So the theorem is, what is the theorem? What is the name of the theorem? Anybody? Can you guess? Here, is it clear my voice?
Yes, sir.
Huh?
Sir.
Theorem?
Green's theorem, sir.
Green's theorem. Okay. Last class lo meeku konni questions ichchanu kada. Write the applications of the integrations, particularly Green's theorem, inkonti Stokes theorem and Gauss divergence theorem. ఎంతమంది నోట్ చేసుకొచ్చారు? నోట్ చేసుకున్నారు? సియా only few. Okay, ఇంకా ఓకే, విశ్వేశ్వరి, అంసిత, ఇంతేనా? వీళ్ళేనా? మిగతా వాళ్ళు లైట్, బాగుంది. Okay, now today we'll discuss Green's theorem. Just we'll discuss only two problems. After that we'll stop. What is the statement of the Green's theorem? See here in the theorem, statement of the Green's theorem. ఉందా లేదా అండి? See here Green's theorem.
ఇది మాకు ఇంతకు ముందు రాలేదు సార్.
రాలేదా? అదేంటి ఫిజిక్స్లో అవ్వలేదు?
ఈ థీరం రాలేదు సార్.
ఏమొచ్చింది మరి?
స్ట్రోక్స్ థీరం ఇంకా
గాస్ డైవర్జెన్స్ థీరం, అంతేనా? గ్రీన్స్ థీరం రాలేదు. ఓకే, గ్రీన్స్ థీరం రాలేదు. ఓకే, now the statement of the Green's theorem is, okay, so let us assume C is closed path and I am assuming the R is the region enclosed by the curve C. That means assume it is the closed path C and this is the our region R. This is the region R. This is the R region. And then directly, so then integral C P dx plus Q dy, and this is the now line integral where P and Q both are, P and Q are continuous functions, and these two have the first order derivatives. So this PQ have continuous first order partial derivatives, and it is equal the integral p dx plus q dy is equal double integral of dou q by dou x minus dou p by dou y, okay, into dx into dy. That means this line integral we are converting into the double integral. So double integral. So this is the statement of the Green's theorem. That means just here we are writing line integral into the double integral. That means integral p dx plus q dy is equal the whole part we can write dou by dou x, double integral of dou by dou x minus dou, so dou q by dou x minus dou p by dou y into dx dy. Okay. Now, so I think in the previous class we have seen the few problems. In the line integral, what is the our third problem? What is our third problem? This is the third problem. Evaluate the line integral x square plus xy dx plus x square plus y square dy. The curve C is square formed by x is equal plus or minus 1 and y is equal plus or minus 1. Okay, so we know that this is the closed path, this is the square region, or we can assume the rectangular region also. Now this path we are dividing the 4 subpaths C1, C2, C3. That means AB is the first path and BC is the second path and C2D is the third path and D2 is the fourth path. And in the C1 plus path, what is we are getting the result? This is the C1 path. So C1 path result is 8 by 3. Already we did. And the C2 path result is minus 2 by 3. Already we did. And C3 path minus 8 by 3. And coming to the C4 path, we'll get the 2 by 3. Okay, so these are the results, C1, C2, C3, C4 results. After adding this all the results, what we get? 8 by 3 first path result, minus 2 by 3 is the second path result, minus 8 by 3 is the third path result, and plus 2 by 3 is the fourth path result. Now after adding this result, now we'll get the 0. Okay, hello. So now same problem we will solve by using the 1, 2, 3, 4. Now we will solve same problem by using the same problem we will solve by using, now it is the question number 1. Question number 1. So just evaluate this line integral. Okay, now this is the first method. Already we know that method number 1. Now come to the method number 2. Now come to the method number 2. Method 2, what is our question? Line integral C. Question గుర్తుందండి ఒకసారి చెప్తారా నోటికి?
x square plus xy dx.
X square plus xy dx, good, plus x square plus y square
X square plus y square
dy, very good. And what is our path? Path is square and x is equal to plus or minus 1 and y is equal to plus or minus 1. Okay, now come to the, now this problem will solve. Let us write proper. So integral, my god, integral x square plus xy into dx plus x square plus y square into dy is equal. Now what is the statement of the Green's theorem? By using the Green's theorem, by Green's theorem, what is the statement of the Green's theorem? Double integral r p dx plus q dy. So first of all you have to identify the what is our p, what is our q. What is the p? P is equal to here x square plus xy and q is equal to x square plus y square. Okay, now what is the here region R? What is the region R? X is equal to plus or minus 1 and y is equal to plus or minus 1. That means this is the now which region? Now come to the double integrals. In the double integral, now this region is now a square. So this is the region is the square region. Okay, assume this is the minus 1 and it is a plus 1 and 1 and minus 1. First line, and this is the second line and third line and fourth line. That means this is our region. Now this is our region. This is the region, and the right end is 1, left end is minus 1, top end is plus 1 and bottom end is minus 1. This is our region. This is our region. Now that means it is equal, sorry, it is not double integral, sorry, single integral. So see, it is equal double integral r dou q by dou x minus dou p by dou y into dx into dy. Now just find the dou p by dou y. What is the dou p by dou y? Is equal to x only. What is the dou q by dou x? Dou q by dou x 2x. Now substitute these values here. After substituting, double integral 2x minus x into dx into dy. Now what are the limits we have? X limits are minus 1 to plus 1 and y limits are minus 1 to plus 1. Okay, and this is our problem. So now double integral x into dx into dy. Just to find the double integral of this function. Now y is equal to minus 1 to plus 1. Minus 1 to plus 1. Okay, next. Okay. Now is equal double integral y is equal minus 1 to plus 1 and x is equal minus 1 to plus 1, x into dx into dy. Now just to find the first of all this first integration. What is the integration of the first one? We'll get the x square by 2 and the limits from minus 1 to plus 1. What is the result here? This result is 1 by 2 minus of 1 by 2, it is entirely 0. 0. But that means the second result also will get the 0. So integral y to 1 minus 1 to plus 1 into dy and integral y minus 1 to plus 1 into dy is equal integral y is equal minus 1 to plus 1 into dy. It is our result 0. But anyway we know the result directly. Okay, Nandi? So it is the second method. Okay, this is our second method. Okay.
Okay, sir.
Now, so says that means the final conclusion is, so line integral we will evaluate two ways: by using directly normal line integration or by using the Green's theorem. Now we will solve one more problem. Next problem. Yes. So this is the first problem. Second problem solve చేసినట్టున్నా. Okay. So this is our second problem. Now we will solve same problem. This is the second problem. Okay. What is second problem? A vector field is given by f is equal sin y I plus x into 1 plus cos y into j. Evaluate integral f dot dr is over the circular path c is equal to, so c given by x square plus y square a square and z is equal to 0. So we know the answer. What is the result here? The result is pi a square. Already we did by using the line integral. So last class we చెప్పినట్టున్నాం. So the result is according to the line integral. ఇది అయిపోయింది కదా మేడం? Here ఇది అయిపోయింది కదా?
అయిపోయింది సార్.
So last class లో మీకు explain చేసినట్టున్నాను by using the line integral, and the what is the result? We'll get the pi a. Okay, but again we will solve by using the Green's theorem. Okay, so before that, now first of all, by using the line integral, just we are converting the total result in terms of polar form by taking x is equal to a cos theta and y is equal to a sin theta. Finally we have the result pi a square. Now same problem we will solve in this method also. Okay, now copy and paste. Okay, now come to the second question here. So the previous one is the first question and this is second question, question number 2, and this one also will solve in the two ways. Now first method number 1. So this is the method number 1. What is the result? Pi a square. Now we will solve same problem in the second method also. Now come to the method number 2. Second method. Now come to the first of all, what is our line integral చెప్తారా? here line integral x is equal to sin y into dx, కరెక్టేనా, ప్లస్ 1 ప్లస్ cos y into dy, ఇదేనా, into x. And what is our path? Path is x square plus y square is equal to a square and z is equal to 0. ఇదే కదా path. Okay, now we will apply the Green's theorem. By using the Green's theorem, now this is equal single integral p dx plus q dy. What is the p here? P is equal to sin y and q is equal to x into 1 plus cos y. And according to the Green's theorem, statement of the Green's theorem is single integral is equal to double integral dou q by dou x minus dou p by dou y into dx into dy. Just to simplify, the dou p by dou y is cos y and dou q by dou x is 1 plus cos y. Now substitute. After substituting, now integral, double integral r, leave it the r also, integral dou q by dou x is 1 minus 1 plus cos y minus cos y into dx into dy. Dx into dy, double integral. But what is our path here? That means our region. What is our region? This is the circular region. X square plus y square is equal to a square. That means it is the right end a, left end is minus a, top end is a, and bottom end is minus a. So this is our region. This is the R region. Now double integral cos cancel, will get the 1 into dx into dy into R. Now I am asking a question. According to the properties, what is the result? What is the double integral of 1? Maybe offline class lo cheppinattunnanu properties of the double integrals, triple integral.
Area of the circle like this.
Very good. So the result is area of the region. Area of the region. Very good. Area of the region. Area of the region. The given region is the circular. What is the area? Pi a square. Okay. This is very simple. But observe, according to the line integral approach, the problem very complicated. Observe here. This is very complicated problem. So we have to convert into total into polar. Then we'll get the result. Okay. The calculation is very tough here. But by using the Green's theorem, this problem very simple. And by using the double integral also. Okay. But I am asking again one more question. So how many ways we can solve this integral 1 dx into dy? Maybe offline lo cheppinattunnanu, gurtunda andi? Gurtunnaya andi? Ayyo, gurtunnaya leva? So anyway we will get the result pi a square. త్వరగా అండి, don't waste your time. Double integral 1 dx into dy. What is our region? X square plus y square is equal to a square. We know the answer. త్వరగా చెప్పాలండి. సాల్వ్ చేద్దామా, వదిలేద్దాం? Solve చేద్దాం. Okay, now we will solve in two ways. First one, we will solve in the Cartesian form, then polar form. Come to then the Cartesian form. So first of all, draw the curve. So this is our curve. Right hand is minus plus a, left right hand is plus a, left hand is minus a, and top end is a, and bottom end is. And what is the curve? The curve here, x square plus y square is equal to a square. That means y is equal, we will write plus or minus under root of a square minus x square. So this is the curve. Now come to the in the integral line, double integral. So double integral r 1 dx into dy. So you can fix the x limits or you can fix the y limits. Now here I am fixing the x limits. What is the right end of x? A, and left end of x is minus a. So that means our x limits are x is equal to minus a, plus a it is, and x is equal to minus a. That means our limits are x is equal to minus a to plus a. And what are the y limits? Y limits are the rest of means vertical. So vertical is the y limits. Now the y limits are y is equal to under minus under root of a square minus x square, here under root of a square minus x square, 1 dx into dy. Now after evaluating the first integration, we will get the x and limits minus a to plus a. That means here we will get the 2a sorry, reverse here, sorry, just a reverse. My god, sorry. Now the double integral r is equal to 1 dx into dy. So first of all you have to fix the x limits. Now x limits is minus a to plus a, and y limits, what are the y limits? Is equal minus under root of a square minus x square to under root of a square minus x square into 1 dx into dy. Now after simplification, the first integration is, we will get the result is 1 integration of 1 is y, and limits y is equal minus under root of a square minus x square and under root of a square minus x square. Now after applying the limits, we will get the 2 into under root of a square minus x square. This is the first integration. Now the second integration, x is equal minus a to plus a into dx, and integral x is equal minus a to plus a into dx. Now integration of this one is 2. Integration of what I under root of a square minus x square is x by 2 under root of a square minus x square plus a square by 2 sine inverse of x by a, limits from minus a to plus a, and after applying the upper limit, so it is 0 and a square by 2 sine inverse of 1. For lower limit, minus a, so 0 plus a square by, so sine inverse of again minus 1. That means 2 into, so a square by 2, it is the pi by 2, minus or minus plus, it is a square by 2 pi by 2. That means here we will get the 2 into 2 a square by 2 pi by 2. So 4 cancel, get the pi a square is the result. So this is the first one, Cartesian form. Similarly, same result we will solve by using the polar form also. What is the polar form here? Now this is the y-axis and this is the x-axis, and we know that what is our path? Our path is circular path, circular path, circular path, circular path. Now what are the r limits and what are the x limits? X limits, r limits, r is equal to 0 to a, and theta is 0 to 2 pi, and dx dy is equal, what is the dx dy is equal to r into dr into d theta, and you have to substitute x is equal to a cos theta and y is equal to a sin theta only. Now what is the here the our integral? Our line integral, sorry, double integral r 1 into dx into dy. This total result we will write double integral, there is no one, so r dr d theta, and limits r is equal 0 to a and theta is equal 0 to 2 pi. Now we can easily simplify this one is integral 0 to 2 pi d theta, first integration, and second integration integral 0 to a r into dr. That means this one is, this first integration is theta limits 0 to 2 pi, and the second one is the r square by 2 limits 0 to a, so 2 pi minus 0, and here a square by 2 minus 0. So here we will get the result is pi a square is the result. Okay, now this is the our this integration result. Okay, my suggestion is no need to solve, just use the properties. Okay, well, మీరు solve చేయాలనుకుంటే better to use the polar form. Okay, is it clear? That is my suggestion.
Okay, sir.
Okay, so it is the second question. ఇంకో క్వశ్చన్ సాల్వ్ చేద్దామా సిఆర్, లేదా హోంవర్క్ ఇచ్చేసేయాలి?
హోంవర్క్ ఇవ్వండి సార్.
ఓకే సో క్లాస్ ఆపేయాలి అయితే ఓకే ఓకే సో ఎనీ వాల్యూస్ హోంవర్క్ ప్రాబ్లమ్స్ మీకు ఎన్ని కావాలంటే అన్ని ఇస్తాం విత్ రిజల్ట్స్ వితౌట్ రిజల్ట్స్ బెటర్ విత్ రిజల్ట్ వద్దు వితౌట్ రిజల్ట్స్ ఓకే homework problem first one evaluate integral c xy dx xy square dy and where c is a square in the xy plane x is equal to plus or minus 1 x is equal to plus or minus 1 and y is equal to plus or minus 1 okay so my suggestion is better to apply the solve in two ways by using the Green's theorem and by using the line integral answer ivala here odu answer no need
ఇవ్వండి సార్
4/3 is the result and the second question is number 2 evaluate line integral c 3x square minus 8y square into dx plus 4y minus 6xy into dy and c is bounded by y square is equal to x and x square is equal to y and the result here 3/2 so 3/2 is the result 4/3 3/2 very good okay and this is the second problem ఇంకో క్వశ్చన్ ఇవాళ హియర్ సరిపోతాయి ఇంకా కావాలా ఇంకా కావాలి
ఇంకా 2 ఇవ్వండి సార్
ఇంకా 2 ఇస్తాను ఓకే బాగుంది ఇంకొక 2 సార్ మరి అన్నీ సాల్వ్ చేయాలి వింటున్నారు
ఓకే సార్
మళ్ళీ టైం లేదు now f is equal to here x square I plus xyj and the c is the square region bounded by x is equal to 0 and x is equal to a y is equal to 0 and y is equal to a evaluate the line integral evaluate integral c f dr f dot dr okay answer is a cube by 2 and the next problem Stokes-Green's theorem okay so now the fourth problem f is equal to 2x minus y into I plus minus yz square j minus y square z k and the C is the curve. C is the curve upper of surface of x square plus y square plus z square is equal to 1. That means this is sphere bounded by, in the projection on the xy plane. Whatever that means. So it is the upper of surface means is the hemisphere. The projection on the xy plane means whatever that means. It is the only circle, because projection on the xy plane means z must be 0. So we will get the x square plus y square is equal to 1. That means our closed curve is x square plus y square is equal to 1 only. Okay, and the question is evaluate C. Now here the result is answer pi. Okay. Okay. So anyway, these 4 problems do in 2 ways, by using the line integral or by using the Green's theorem. Okay. But again, these 4 problems we will solve in the different method. Different method means we will apply the, what is the next theorems here? Stokes theorem.
Stokes theorem.
So same these 4 problems and the previous class problems also we will do by using Stokes theorem. Okay. So anyway, I will stop now. Thank you to all.